In this lecture, we'll speak about social choice functions. The most famous impossibility results pertain to social welfare function, and in particular, the Arrow's impossibility theorem is widely known, and we have discussed that before. Now, it might be thought that the problem lies in the fact that social welfare functions require you to specify as an output of the process an entire ordering, and that might be highly constraining. But if you only needed to pick a winner, as does a social choice function, then you would escape these paradoxes. It turns out that the answer is no, but first we need to sort of redefine our criteria a little bit, because the notions of Pareto efficiency and independence of irrelevant alternatives just aren't well defined in the context of a social choice function, but we will see that there are closely related notions that are well defined. So let's first define weak Pareto efficiency. And we'll say that a social choice function C is weakly Pareto efficient if essentially it never elects a dominated outcome or candidate. So if there is a candidate O2 such that there is some other candidate O1 that is always preferred to O2 by every voter, then the weaker candidate O2 would never be elected. Seems like a reasonable criterion, and we'll call that weak Pareto efficiency. In place of independent of irrelevant alternatives, we'll have the notion of monotonicity. And informally, as is written here at the bottom, it says that if you have a winner, if we increase the support for that candidate, they would still remain a winner. So formally speaking, we'll say that the social choice function is monotonic if we take any candidate, O, and if it's the case for any preference profile, this one over here, if under this preference profile O is selected, then if we look at any other preference profile, if it has the property that for every agent and every other outcome O prime, if under the original preference O was preferred to O prime, it is also under the new preference. So that original winner O never lost support, maybe only gained support. Then under those conditions, it better be the case that under the new preference order, in which O only got more support, it would still be the social choice, the winner. Again, a reasonable property to require. The last notion of dictatorship, similar to what you see in social welfare, simply says that C is dictatorial if there's some agent whose top choice is always the social choice. This is the bad news. The Muller-Satterthwaite theorem tells us that we can't have all three. So if a social choice function is Pareto efficient and monotonic, it must be dictatorial. And so, after all, social choice functions aren't more benign than social welfare functions, and we won't go through the proof, but the intuition is that in order to determine the relative ordering among candidates, we need to sort of probe it everywhere. And if we probe it enough, we'll get the entire social welfare function. And since the function, the social choice function, must be defined for all inputs, as we vary the inputs, we can find the total social welfare ordering. So in fact, we can use the social choice function to recover the social welfare function. That's the intuition behind the proof, and why social choice functions are as maybe counterintuitive or complicated as social welfare functions. Now, just to test our intuition again, let's consider an example, and let's take plurality, which perhaps on the face of it might contradict the Muller-Satterthwaite theorem. Clearly, plurality is Pareto efficient. In other words, if everybody prefers some candidate to another candidate, that other weaker candidate will never be the choice. And it's not dictatorial, obviously. So the theorem says it cannot be monotonic. Intuitively, you might think it is monotonic, but here's a counterexample. So here are these 7 agents and their 3 preference profiles. The 3 of the agents prefer A to B to C, etc. And clearly then A would be the winner under plurality, because 3 agents would vote for A. Now, what happens if we go and we modify this preference to this preference? We simply make A's situation better. C was preferred to A originally, and now A is preferred to C, and all other preferences relative to A remain the same. So surely you would say A is doing as well as it would have done originally, and monotonicity would say that it would still be the winner, but clearly in this case there are now 4 agents who are voting for B versus only 3 for A, so B would be the winner now. So plurality is not monotonic.